Hey, welcome to lesson 4.2 on probability. And so in this one, we're going to go ahead and take a look at two different types of probability. One that is called theoretical probability, and then the other is experimental. And so when we talk about theoretical probability, this is when we're just thinking about like what would be the probability of something, like tossing a coin, and versus actually flipping a coin. So here we have theoretical. What's the probability of getting heads? Well, there are two sides, right? And theoretical probability is simply how many favorable outcomes you have divided by the total number of outcomes. Well, on a coin, there's only one head, right? One side has a head. There are two sides, so there are two outcomes total. Only one of those outcomes is heads. So it's 1 over 2, which is 0.5 or 50%. It is okay to express probability in all three forms. You can express it as a fraction, a decimal, or a percent. They all represent the same thing. Well, what about experimental? Well, experimental is where you actually flip the coins. And so in one of the classes, I passed out pennies, and people flipped the penny 5 times and reported what they got. So this person got 3 heads and 2 tails. This got 1 head and 4 tails, etc. And then I added up, well, how many total heads were there? 35. How many total tails were there? 30. And then that means there were 65 coin flips that happened. 35 of those 65 were heads. And so when I do the division, I get 0.54 or 54%. I guess technically you could reduce this fraction to like 7/13. But any of these expressions are valid. Now, why didn't I get 0.5? Well, experimental, there are reasons why experimental doesn't match probability. Probably the best one is not enough trials. I mean, it's just chance. So it doesn't mean that if you flip one head, the next one's going to be tails. There's no guarantee for that. The probability is 50% every time. And so experimental probabilities aren't going to match theoretical exactly. Typically, they won't. But the more trials you do, the closer it will match. So, here we did 65. What if we did 1,000? If we did 1,000 flips, we probably get a percentage that is going to be closer to 50 than to 54, right? So the values will get closer and closer to 50% the more experiments you do. So why do we have theoretical and experimental? Why not just do everything theoretical? Well, you can only do theoretical with certain things. So let me give an example. If we decided to run a restaurant, we were doing lunches, and we did sandwiches, salads, and burritos, right? So as an example, so we did sandwich, salad, burrito. There are 3 outcomes. What's the probability somebody's going to get a burrito? 1 out of 3? 33%? I don't think we can say that, because it's just not a random choice, right? When you're doing this type of probability with theoretical, with the coin flip, it's random, right? You don't know which one. But here it's going to be based off of people's preferences. So if more people like burritos than sandwiches and salads, and I don't blame them, I do. I would choose the burrito over either of these. You're going to get more burritos, right? If this is the favored item. So it's not random chance. So in this case, theoretical doesn't make sense. There's not a 33 and 1/3% or a 1 out of 3 probability equally for each of these, because it's based off people's preferences. So in this case, you would do an experiment. Open up the cafeteria for the day. See what people order. And then you'll have a good idea. And then maybe you find out that 50% of the people got burritos, 40% got sandwiches, and 10% got salads. And then you do it the next day, and you do multiple days, and you start to get a collection of data so that you can predict how much you're going to sell. And so that kind of gives you a really good idea. You might find that you sell less burritos in the summertime and more salads and sandwiches because people prefer maybe a cooler meal when it's hotter outside. So there's lots of ways to kind of collect this data and look at it. But experimental makes the most sense in this situation where theoretical doesn't make sense to do at all. So that's why we have two different types. But if you're talking about a coin toss, rolling of the die, those things theoretical absolutely makes sense for. All right, so let's take a look at this next part here. And for this, I'm actually going to switch to some empty notes. The first one I think was much easier just to copy everything down, but for this I think it's good to talk one item at a time. All right, so for this one here, we have a bag, and it has like marbles in it. So you have 4 red marbles, 3 red marbles, and 1 green marble. How many total marbles? Well, if we add that up, that's going to be 8 total marbles. Now this is going to be theoretical because you have an equal chance of pulling any of the marbles. And you're doing it randomly, you're just sticking your hand in the bag and you're pulling out 1 marble. What is the probability it's going to be red? Well, this is favorable over total. So you have 4 favorable outcomes. There are 4 reds, there are 8 marbles. So your probability is 4 over 8. Now we do want to reduce that to 1/2, and that is 50 or 0.15, which is also 50%. Probability, once again, can be expressed as a fraction, as a decimal, or a percent. All 3 are acceptable. What's the probability of pulling a blue marble? Well, how many blue marbles are there? There are 3. 3 out of 8. So this as a decimal is 0.375. And as a fraction then as a percent, 37.5%. And then for our last one, what's the probability of pulling a green marble? Well, there's only 1 green, so there's 1 favorable outcome out of 8. So that would be 0.125, or 12.5%. And then for our last problem here, what's the probability of pulling a blue or a green? Well, both of these are acceptable, right? And so you have to include both of these as favorable outcomes. There's 1 blue, there's 3 greens. So you have 4 favorable outcomes, which is 1/2, which is 0.5, which is 50%. All right. So that concludes page 1 on the lesson of probability. Please continue on to page 2.